Okay, we're going to be good at this one. Here's a bunch of work in answers there. So they give us a big giant graph. That's the graph of f. And g is the integral of f. So then right away, I wrote down that g prime was equal to f because the derivative of the integral is just the inside function. So g prime is equal to f and g double prime is equal to f prime. So letter A, it says, what is g prime of 8? So g prime of 8, g prime is equivalent to f. So g prime of 8 is equivalent to f of 8. This is the graph of f. So at 8, when x is equal to 8, the y value is equal to 1. So f of 8 is equal to 1. So they need to kind of see g prime is equal to f, and then we can give our answer. Part B, we got to be real careful how we're writing our answer here. You're going to find all the values where the graph of g has a point of inflection and give a reason for your answer. So I'm going to show something to you on the rubric here, but I'm going to talk myself into getting this right answer here. So I know g has an inflection point where the second derivative changes sign. The g double prime is equivalent to f prime. So if I'm asking where does g double prime change sign, I also is the same thing as me asking where is f prime changing sign. And we know that the f prime is the derivative of f, which is the slope of f. So I want to know where the slope of this given f graph changes sign. That's where that graph changes direction. That's where that graph changes from increasing to decreasing or decreasing to increasing, from going up to going down or going down to going up. So that's where you're going to look at to get your answers. And then we're going to include that in our justification right there. So I got these three numbers because look at -3. -3, this function changes from decreasing to increasing, from going down to going up. So the slope is negative and then the slope is positive. So the slope changes sign there at x equals -3. Also the same thing as x equals a +3. It goes up and then it goes back down. This just keeps on going up. And then here it goes down and it goes back up. So where it changes direction, that's what we got going on there. So there's a few different things that they can apply. If you don't have this connection where the slope of f changes sign, you won't get full credit for that. Like if I take that away and I just put g double prime equals f prime changes sign, you'll get some credit, but not full credit for that. And so I got the answers down there. I mentioned that, but at some point they need to see that's where the slope of the f is changing sign. So what I did, I found the rubric that the AP graders are using for us there, and see if you just put has an inflection point because g double prime equals f prime changes sign there. That doesn't give you, that gives you this point, but it doesn't give you this other point there. So these three things are the acceptable answers right there. Like we could mention like the three answers, but then you can mention because it changes from increasing to decreasing or decreasing to increasing there, or you can mention because the slope of f changes sign there. That's what I kind of stress here. The slope of f changes sign. Like they're gonna need to see that in there, and that gets you all the points on that problem. Or you can say because that's where the graph of change obtains a relative extrema. Because if you think about it, if it goes down and goes back up, that's a relative min, goes up and goes back down, that's a relative max and a relative min there. So those are the few items that you could have to get full justification, full credit for that particular problem. All right, letter C, we got to find these two things. They do put on the rubric, you need to label like g of 12 equals something, g of 0 equals something, like label which is which, right? Seems like it's pretty common sense there, but g of 12, so they give us this equation for g of x. So if I tell you to find g of 12, you got to take that 12 and plug it in for that x right there that's attached to the integral. So we're going to do the integral between 6 to 12. You know that integral means area, so you're going to do the area of this f graph between 6 to 12, that's 1/2 times base times height through the area of that triangle to get 9. And then right here, you're going to take the 0 now, plug that in for the x there. So the integral between 6 and 0, when it's not least the greatest like that, flip it around, make it the opposite sign there. So put a negative between 0 and 6, and then between 0 and 6, that's a half of a circle. That's a semicircle. So that negative is there because we flipped the numbers, and I'm going to do pi times the radius squared divided by 2, which is 9 pi over 2, and then part C is done. And the nice thing is we get to use those numbers in part D. So part D is talking about an absolute minimum over a closed interval. So this is an absolute extrema problem. We're going to make an XY chart or an XG chart. We're going to need to include the endpoints. So -6 and 12 are in there, and also any critical numbers. So the critical numbers is where the G prime, which is the same thing as F, is equal to 0. And so that's at like -6, +0, or positive 0. Negative 6, 0, and a positive 6 right there. Negative 6 we're already checking. And then 0 and 6 we're including as our critical numbers. So the nice thing is the 12 and the 0. So this one and this one, where I got these arrows, we already found that from part C. I already know that's negative 9 pi over 2, and I already know that's 9. And then the other ones, we're going to take the negative 6 and the positive 6 and plug it into our g function, because that's what we're trying to minimize here. So g of negative 6, just plug the negative 6 in for that x right there. And then I flip them around, and I did the area between negative 6 and a positive 6. But when you look at the graph between negative 6 and a positive 6, you got an equal amount of area above and below that x-axis there. So that's why that ended up being 0. And then when you plug in 6, the integral between 6 and 6, that's just the integral, like the area of a point. When you got the same number right there, that's also going to be 0. And so if you look at the highest, or no, we're looking at the lowest y value here. We got, it actually says find the value of x at which g obtains all right, so the absolute minimum. So you're looking for the lowest y value, which this is the only one that's negative right there. And it says find the value of x. So if it says what is the minimum value, you're giving them that. But if it says the value of x, you're going to say, hey, it attains that absolute min at the x equals 0. And then let me double check my notes to myself there. We mentioned the rubric, we mentioned the labeling. And so I think we are good there. Abacus.